Hey everybody, we are going to do a video today called 7.2, How Can I Find a Sum Without Using Algebra Tiles? So hopefully if you're watching this video, then in class you have been working with the algebra tiles most likely. And we've been working on this process of going from a sum to a product and a product to a sum, but all with the algebra tiles. And today we're going to kind of get into how can we do this without using the tiles, like without having the tiles in my hands? Because eventually that's where we got to get, right? You can't always carry a bag of algebra tiles with you wherever you go to solve problems. That would be kind of strange. So we're going to try a problem today. We're going to do an example in this first video, and this is it. Please write it down. Example 1. We are going to multiply x plus 1 times x plus 2. Parenthesis x plus 1 times parenthesis x plus 2. And what I'm going to do is underneath of this, I'm going to label that currently this is what I call a product. I am multiplying two things together. But I want to rewrite this in a different format. I want to rewrite this as a sum. So I'm going to demonstrate something here. And for the video for right now, you probably can just watch this part. I'm going to demonstrate how to do this problem with the tiles first. So if I have x plus 1, what that means is I have x plus one little unit as what I would call my length of my rectangle. Now remember, we're dealing with rectangles, so this is my length times my width that I can write down. So I have x plus 1, and then my width is x plus 2. So let's see, x plus 2 means I need two little units. So here is my width, something like this. And what I'm going to do is I'm going to figure out what fits inside this space to make a perfect rectangle. Now this is what we've practiced in class. So I know I could probably fit an x squared kind of perfectly into that corner. I'm probably thinking like maybe on top fitting an x right here. And let's see, maybe like an x here for this length, maybe another x here, and then of course some little units to fill in those gaps. So a little unit here and a little unit here. And like I said, if you're watching this video, I hope you've done this process before. So I'm going to pull the length and width back off, and look what we've created. We've created a rectangle. The length is x plus 1, the width is x plus 2, and the inside is x squared plus 1, 2, 3 x's plus 2 units. So I already know my answer. My answer is x squared tile plus 3 x's plus 2 little units, and I'm done, and I've got that answer. Now, like I said though, we're trying to figure out how can we do this without needing all of these resources. The algebra tiles are great, but you can't have a bag of algebra tiles everywhere you go. So I'm going to teach you a second strategy today, another way that we can do this that doesn't require the tools that we have. So now grab your pencil and definitely write this down in your notes. We are going to use a process called the generic rectangle. The generic rectangle. Generic means we're going to come up with a process that we can all use. Think of like, do you ever go grocery shopping for like cereal? If you go down the cereal aisle, there's all the like name brands that everyone knows, like Cheerios and Fruit Loops and Apple Jacks. But there's also what we call the generic brands, where you're like, oh, okay, here's a box. It's the same thing as Cheerios, but it's the store brand called like O's or something like that. Or instead of Fruit Loops, they're Fruit Rings, generic brand. So we're going to come up with a generic process, and here is how it works. We're dealing with rectangles. So what I'm going to do is draw a rectangle. But I'm not going to draw any algebra tiles. That is not my plan. I'm not going to do any tiles. Instead, what I'm going to do is just label my length and my width. Now we know the length is x plus 1, and we know the width is x plus 2. So I'm going to write here x plus 1. And x plus 2 means I'm going to write x plus 2 for my width. And then watch my process. My plan is I'm going to split this down the middle, and I'm going to split this down the middle. Now, if my length is x plus 1, then what's my length on the opposite side? Same thing, x plus 1. If my width is x plus 2 on the bottom, what's my width on top? X plus 2. It's the same thing on both top and bottom, left and right. And now I'm going to go through and find the area of this rectangle by looking at each of these corners. That's my plan, is to focus on the corners. So in this corner, I have an x and an x. So if my length times width was x times x, what's x times x? X squared. Let's circle that. That's that corner. In this corner, I have 2 times x. 2 times x is 2x. There's the area of that section. Let's circle that. In this corner, I have a 2 and a 1, so I have 2 times 1, which we all know is 2. So that little area is 2. And then in this final corner, I have 1 times x, so that's 1 times x, which I know is just x. I'll circle that. So the area of my generic rectangle looks like it's x squared, right there, plus these 2 x's, okay, plus this x over here, okay, plus this extra 2. And I could leave that as my answer, but I could simplify just a tiny bit. I can combine these like terms. 2x plus another x is 3x's. So I have x squared plus 3x's plus 2. Well, isn't that the exact same answer we got up here? This is a perfect match to our answer with the algebra tiles. And so this is a cool process. That's the generic rectangle. I didn't need the algebra tiles, and yet I still got the exact same answer by drawing my rectangle and labeling my dimensions and multiplying those corners. So it's a really cool process. It works really well. I'm going to have further videos on how to use this generic rectangle. Basically, it's a shortcut to get away from the algebra tiles because eventually you just can't use them all the time. Same idea as the algebra tiles. We're still talking about areas and rectangles, just an easier, quicker process. So please keep watching more videos on this, and thanks for watching this first one, guys. Bye.